Today I will teach you the easiest and the fastest way to solve inequalities. You don't have to substitute and check whether positive or negative, no steps like that. So let's get started. So we have a question like this, and the first step is to check if there is 0 on one side, and yes, we have a 0 on this side. And sometimes there will be questions like x square is greater than x, something like this. Then there is no 0 on this side, so shift the x to the other side and x square minus x is greater than 0, and then you should proceed. So first step is done. Second step is break into linear factors. So there are several brackets here. We should split each bracket into their linear forms. So x square should be written as x into x. This we could write it as x minus 3 into x minus 2, and 5 minus x we could write it as 5 minus x into 5 minus x. So that's the second step. Now the third step is make coefficient of x positive in each bracket. So in this bracket coefficient of x is already positive, but in this bracket coefficient of x is minus 1, right? So we should make that positive. And how will we make it positive? We simply multiply minus 1 to this bracket and also to this bracket. And you know that when we multiply minus 1 on both sides, the sign changes, but there are two minus 1s, so the sign doesn't change. So our new equation is x into x. So step 3 done. The next step is find critical point of each bracket. So what is critical point? Simply you could find the critical point by equating each bracket to 0. So for this bracket x minus 3 equal to 0, that means x equals 3. So likewise for each bracket there is a critical point. For this is 3, for this bracket it's 2, for this bracket it's 5, this bracket 2, 5, and for these two it's 0. Substitute x equal to 0, you will get 0. So we found the critical points. The next step is plot all critical points on number line. Okay, we have a number line, so we have 0, 3, okay, 2 and 5. Now there is an important thing. You could notice that there are two zeros, right? So instead of this we'll just darken this line, because there are two zeros here and 5, 2 are 2 in number, so we'll just darken this. That's it. So that's step 2 done. And then put plus sign after largest point and then alternate sign unless critical point is repeating. So after the largest number, that is 5, we put plus sign, then alternately we will put minus plus minus plus. But only one thing in mind, you should notice that if it is dark or if it is 2 in number, we won't change the sign. We'll again put plus, then minus, then plus. Again this is dark, so we won't change, plus. Done. And you should remember that if this 5 was 3 in number, that is odd number, then we should alternatively change. If it was 3, one more x minus 5 was there, then we won't change it to plus, directly we will write minus. So that's step 2 done. Next we should look which all places is suitable for our answer. So this side should be greater than 0, right? So that means this side should be positive. So between 3 and 5 it's positive, between minus infinity to 0 it's positive, and 0 to 2 also it's positive. So our element x is an element of minus infinity to 0 union 0 to 2 and union 3 to 5 union 5 to plus infinity. So that's our answer to this inequality question. So here's a trick without substituting, and we simply got the answer. But what's the logic behind this? Each bracket could either be positive or negative, positive, negative, or 0. And if the entire thing turns out to be negative, inequality is false. And if the entire thing turns out to be positive, then the inequality is true. So first what we do is, for each bracket we take it separately. Each bracket we take as separate entities, and what we do is we find the critical point. And what is the critical point? Critical point decides the sign of this bracket. If the value of x is greater than 3, then this entire bracket will be positive. If the value of x is less than 3, then this entire bracket will be negative. And if the value of x is equal to the critical point, then this bracket will be 0. So that means critical point decides the nature of one bracket. So for each bracket it's like that. Here we got x to be 2. So if it's greater than 2, this bracket is positive. Less than 2, this bracket is negative. And if it's equal to 2, it's 0. But in this case, it's kind of opposite. If the value of x is greater than 5, this entire bracket will be negative. If it's less than 5, this entire bracket will be positive. That's kind of the reverse way relative to these brackets. So what do? We simply make the coefficient of x positive, and then this 2 behaves like these two brackets. If it is greater than 5, positive, less than 5, negative, right? So we understood how critical points affect the nature of the bracket. Then what we do? We plot the points, and if any number is lying on this side, it means it is greater than 5, it is greater than 3, and it's also greater than 2, right? All three numbers. That means all the brackets will be positive. So that's why the entire expression will be positive. And if we shift on this side, it is greater than 2 and 3, but not greater than 5. So this bracket alone changes to negative, and these two will be positive. So the entire expression is negative. And on this side, so we will get two negative brackets. This will be negative, and this bracket will also turn negative. So two negatives will make positive, so the entire expression is positive. And on this side, once again it's negative. And if there are repeating brackets, then that means one extra negative will be formed. So negative and negative again positive. So that's why alternate effect won't take place. So that's the logic behind this simple trick. And before I end, I like to give two tips. One tip is to take care of domain. So suppose there's a question like x minus 3, x minus 5 greater than or equal to 0. Here we have two critical points, 3 and 5, and it's greater than or equal to. And if it is equal to, then we should consider the critical points also in the set. That is x element of some values. I'll explain it. So here it's positive, negative, positive, and we want values greater than 0, right? So all the positive things, minus infinity to 3 and 5 to infinity, and this bracket is closed bracket because 3 is also included. Why? Because if I substitute 3 in this bracket, what will happen? 3 minus 3 is 0, so the entire expression is 0, and it is equal to 0, right? So that too is true, so this is closed bracket. But here, if we substitute 5, we will see it's coming in the denominator, and in the denominator 0 is undefined, so we don't include 5 in the set. So always take care of the domain. The domain of this equation doesn't involve 0, so we should not involve the value which makes the expression 0, that is 5. And the other tip is send always positive and always negative brackets at the side. And what do I mean by this? There's a question like this. So this entity is either always positive or 0 for any value. If you put minus 2 or 3 or minus 1, any value if you put inside for x, it will either be positive or it will be 0. But for this bracket, sin x or sin value is always between minus 1 to 1. So 5 minus 1 or 5 minus minus 1 is always positive. So this bracket is always positive. And whenever you have a always positive bracket, we could send it to other side. That is by dividing 5 minus sin x on both sides. 0 by 5 minus sin is 0. So x square is greater than or equal to 0. So always in such cases you could send it to other side. That's it. Thank you for watching and bye.